Hello, this is Stephen Neshiba, and I'm here to give you a kind of a compliment to the Pecha Kucha presentation that is scheduled for May 16th. Mine is called Discoveries and Challenges of Flipping a Science Course, and I'll jump right to the presentation. Flipping General Chemistry Lessons Learned. So the situation, as I've described it here, was that we have a kind of a chronic overload of chemistry students, and this is part of a persistent trend in sciences, not just at UPS, but also nationally. And to kind of demonstrate that, I thought I'd go to this graph that there's this general increased demand for science at UPS, and here are some national numbers in STEM here given in purple. That's kind of showing the same trend. So there's various solutions to this. We can accept bigger classes. The university can hire more instructors. There are problems with all of those, which you can read if you like. But the solution that I thought I would try this year was to do what's called flipping the classroom. What is flipping the classroom? Well, the idea is that before class, I make a video, students watch that, and then during class, students might do some of that, some of the homework associated with that video. And here's an example of some happy students. This was actually at the end of the course, so they're all actually already done with their homework. So as it turned out, the course turned out to be a blend of flipped and conventional pedagogies. So I'll just focus on a few of those. Monday and Tuesday, that was pretty much homework, quizzes, lecture. That was pretty much a conventional format, except that we did spend more time with all 40 students doing homework. But the real change came on Thursday and Friday with what I called a computational guided inquiry. I was able to break the sections up into 20 student sections, and then could really focus on the activities for those days. Now, this is in addition to once a week wet labs. That's our sort of standard 18 student sections. And as often as needed in the structure of this course, I would prepare videos. Sometimes that would summarize a past lecture. Sometimes it might provide some remedial information or prepping for lab, that sort of thing. So, but I really want to talk about these Thursday, Friday computational guided inquiry sections. So, what are those? Well, what we ended up doing was I would design these computational exercises. There's one here that talks that's this program called Spartan, and that's a new piece of software out there that I'm really quite excited about. In fact, I brought up a little demo here for you, the sort of thing that you can do in Spartan. Here's an amino acid that you can bring up. Students can bring up. They have their own copy of this. And so there's lots of things they can do. For those of you who know all about this sort of stuff, you can do various sorts of quantum mechanical calculations on them. Here's a fun thing that you can do. You can just add on some water molecules, and you can see how things interact with water, especially showing, for example, how the hydrogen bonding works between this amino acid and the water. So that's one piece of software that's pretty key, and students are able to use that and get insights into sort of what the nature of chemical reactivity is, chemical structure, and it just wouldn't have been possible without this structure. So students do some preparation for these computational exercises, and I might have a video walkthrough. It makes it really easy to teach them the software because I don't have to write it all down. I just do it myself, demo it, they can pause, and so forth. Now, of course, in addition, there's lots of tutorials and presentation, and I've shown how students interact with that. Finally, what are the lessons of this sort of pedagogical approach that I got? Well, there's a strategic use of technology can efficiently yield better student outcomes regardless of class size. I believe that is true. There's especially via these things called computational guided inquiry that I just showed you. That's in small breakout groups, 20 students or fewer with me at a time. And there's issues about learning that include repetition, personal attention, that are really important for students. A lot of students have come up to me afterward and said, "I love that video, and I watched it 5 times so that I could really get it." A lot of students really took advantage of that, but especially those with alternative learning styles. They really benefited from being able to watch video lectures multiple times. There's a kind of a diversity component to that statement. Uh, there's a lot of in-class group study as a result of this format, and one of the unexpected benefits of that was that it leads to more out-of-class engagement. There's a lot of talk in the hallways, these activities. I think that's only possible because we've modeled it in class quite a lot. There's this concept called asynchronicity, and that has to do with how students, the timing with which students learn and the timing with which I interact with students. And perhaps in the question and answer period, we will be able to talk about that a bit. And finally, in sort of looking at the larger view, focus on key competencies. What is really absolutely essential about a degree in chemistry or a course in chemistry? My thinking on this is that what these what these online technologies allow us to do is really to focus on those. And I think my time is up.